Imagine the Sahara Desert today, an immense expanse of parched sand and rock. It is one of Earth's most formidable and arid landscapes, stretching across 11 countries. But what if I told you this desolate region was once a vibrant, green paradise? For thousands of years, the Sahara was a lush savanna, teeming with life, rivers, and enormous lakes. This incredible transformation occurred during what scientists call the African humid period. It wasn't just a brief moment, this period lasted for millennia, not centuries. The most recent Green Sahara spanned from about 11,000 to 5,000 years ago. During this time, the desert bloomed, supporting a rich biodiversity unlike anything seen today. So, what powerful forces could possibly turn a vast desert into a thriving ecosystem? The answer lies in subtle, long-term changes to Earth's orbit around the Sun. These are known as Milankovitch cycles, named after Serbian geophysicist Milutin Milanković. One key factor is the Earth's axial tilt, or obliquity, which varies over 41,000 years. A greater tilt means more extreme seasons, with more intense summer sunlight in the northern hemisphere. Another crucial cycle is precession, which dictates when Earth is closest to the Sun during its orbit. Approximately 9,000 years ago, the northern hemisphere experienced its summer when Earth was closest to the Sun. This orbital alignment led to significantly increased solar radiation reaching North Africa. More intense summer sunlight supercharged the West African Monsoon system. The monsoon is a seasonal wind pattern that brings heavy rainfall to tropical regions. With increased solar energy, the North African landmass heated up dramatically. This heating created a stronger thermal low-pressure system over the continent. The low pressure pulled moisture-laden air from the Atlantic Ocean far inland. Consequently, the monsoon rains extended much further north than they do today. Rainfall across the Sahara was drastically higher, transforming the landscape. Vast networks of rivers, now dry wadis, once flowed freely across the region. Lake Megachad, for instance, was once larger than the Caspian Sea, Europe's biggest lake. Its ancient shorelines are still visible in satellite imagery, a testament to its former grandeur. Evidence of this green past is abundant and fascinating. Ancient rock art across the Sahara depicts animals like hippos, crocodiles, and giraffes. These creatures require permanent water and lush vegetation to survive. Archaeological sites reveal human settlements along these ancient rivers and lakes. People thrived, fishing and hunting in what is now an uninhabitable desert. Fossilized pollen grains tell us about the types of plants that once flourished. Sediment cores from ancient lakebeds contain layers of organic matter and freshwater diatoms. These microscopic algae confirm the presence of extensive freshwater bodies. Animal fossils, including those of fish and amphibians, further support the Green Sahara hypothesis. Even today, isolated pockets of relict species exist, remnants of a wetter past. This period allowed for significant human migrations across North Africa. It provided pathways for early humans to expand out of Africa and into other continents. The Green Sahara was not a static environment, it experienced smaller fluctuations. However, the overarching trend was one of sustained humidity for thousands of years. Then, around 5,000 years ago, the orbital cycles began to shift again. Earth's axial tilt decreased, and the precession moved summer further from the Sun. This gradually reduced the amount of solar radiation reaching North Africa during summer. The powerful West African monsoon began to weaken, retracting southward. Rainfall diminished steadily, leading to a slow but inexorable desertification. Lakes shrank, rivers dried up, and vegetation withered, giving way to sand dunes. This transition forced humans and animals to migrate towards the Nile Valley or south. The desertification was a natural process, driven by astronomical forces, not human activity. Understanding the Green Sahara teaches us about Earth's dynamic climate system and resilience. It reminds us that even the most desolate places hold secrets of a vibrant, forgotten past.